First and foremost, when solving a linear constant coefficient differential equation, we have to assume yx equals e to the rx. If we now differentiate this, yx would equal re to the rx. And if we differentiate it, again, we're going to get r squared e to the rx. We now take all these lovely things and we substitute it in here. So you're going to get r squared e to the rx plus 4 erx plus 3 erx, which equals 0. Let's now pull the erx out, and you're going to get r squared plus 4 plus 3 equals 0. But now if we divide both sides by erx, this will disappear, obviously. This will vanish. So that means we've got r squared plus 4 plus 3. If I obviously solve this quadratic, it's going to be r1 is minus 1 and r2 is minus 3. Roots are real and distinct, so the general solution when dealing with homogeneous linear differential equations is yt, which equals c1e to the minus t plus c2 e to the minus 3t. So obviously the values that are unknown, the ones that we find here, you plug them up here, where c1 and c2 are constants. So we know that y0 equals minus 2, and obviously the second one. So we can plug those in. So when y0 equals, we can then get c1 e to the 0 plus c2 e to the 0, which equals c1 plus c2, which equals 2, which is equation 1. If we now differentiate this once, so let's do yt, that's then going to become minus c1 e to the minus t minus 3 c2 e to the minus 3t, and now let's bang that in. You're now going to get y equal minus c1 minus 3 c2, which equals 10. We now have two equations, simultaneous equations, and we can subtract them, substitute, whatever. I'm just going to add them both together. So we're going to get c1 plus c2 plus minus c1 minus 3c2 equals 2 plus 10. So that's now going to become minus 2c2 equals 8. Therefore, c2 would equal minus 4. We can now smash that back into any of these. I'm going to sub it into 1. So obviously if we put minus 4 in here, then you're going to get a value of, wait, that should be minus 2, shouldn't it? Yeah, whoops, that should be minus 2 equals minus 2. Yeah, almost missed that. So therefore, when you plug that in, you're going to get minus 4 here, and then that is then going to mean that C1 is 2. Therefore, the general solution would be yt, which equals, now we can sub in to here, our two solutions are C1 and C2, 2e to the minus t minus 4e to the minus 3t. That's it. Easy.